Hello, everyone from GTC. My name is Peter Wu from ASUS Cloud. In this session, it's an honor to introduce our recent project in National Taiwan University Hospital and how we use our AI platform and the GPU servers to accelerate our customers' project. ASUS Cloud is coming from ASUS Group. As you know, ASUS is one of the most popular PC company in the world, and ASUS is passionate about technology and driven by innovation. And ASUS Cloud is a subsidiary of ASUS. ASUS Cloud is focusing on providing enterprise-grade AI and the data platform to help our customers to do a good digital transformation project. ASUS Cloud has several proven track records in recent years. One is a public cloud service for ASUS that we built 3 data centers in Taiwan, United States, and Europe to provide millions of users cloud services. And the other project is we help our government to have a large AI supercomputer cluster that help startups or researchers to have a good AI platform. In this project, we call Taiwania 2, it was listed in Type 500 in 20th in 2018. And in this cluster, there are over 2,000 V100 GPU accelerators. And ASUS Cloud provides software and integration in this project. Besides providing cloud and AI technologies, ASUS also collab with major Taiwan hospitals since 2012 to help these hospitals to do digital transformation project. You can see that there are over 30 different hospitals have project with ASUS, and we are doing applications from dementia to emergency department or to telecare services. And you can see that there are over 5 entities in ASUS Group that co-op together to help hospitals in this project. In order to enable digital health or digital transformation projects for hospitals, we provide 3 kinds of technology platforms in different scenarios. One is a AI platform focusing on try to democratizing AI apps. And the other is we provide a big data platform to help hospitals to integrate data from phenotyping data, genotyping data, or environmental data. And the third platform we call it a medical IoT platform. That technology help hospitals to integrate IoT devices from wearable devices or our portable ultrasound devices to provide telecare or telemedicine services. And in this section, we want to share a project we co-op with National Taiwan University Hospital, the project called Smart ED. That means Smart Emergency Department Project. The project background is try to solve ED crowding and patient safety problem. That problem places in worldwide. You can see this problem in hospitals everywhere. And the project is sponsored by Ministry of Science and Technology. And it's a 3-party cooperation led by National Taiwan University AI Center and co-op with hospitals and ASUS. And in this project, we're trying to using AI to plan and introducing this kind of technology in all ED process. The core idea of this project is to have a protocol re-engineering for ED patient flows by using AI technologies. You can see that in this slide that we are trying to provide an end-to-end flow engineering from registration to audio or visual analysis of patient appearances, into diagnosis, into examination, into observation, and to discharge. It's a whole process or end-to-end flow for patient flow. And there are huge opportunity for AI to try to solve problems in this process. And because there are several PIs or project members trying to do different AI tasks, so the major project challenges or technology challenges is to provide an easy-to-use AI platform and try to fabric different AI data to accelerate AI OT development in this project. And because the major technology challenge is a single or easy-to-use AI platform from the hospital, therefore, in this project, we provide ASUS Cloud AI Platform, and we try to solve our customers' major problems in this project. And let me introduce our AI platforms step by step. There are 4 layers in ASUS Cloud AI Platform. The first layer is an infrastructure layer that we use cloud technologies to integrate different cloud resources, from computing resources, GPU resources, to storage resources, and to network resources. And the second layer is a resource management layer that we try to integrate many AI frameworks in this platform, and then we try to provide some visualization or multi-tenant features that help our users or hospitals to manage these resources. And in these 2 layers, we call ASUS Cloud Infra. It's a part of our AI platform. And the third layer is AI pipeline, that we provide several AI ops features that try to help different AI users try to provide easy to use or turnkey or some integrated SDKs from different AI users, try to solve their problems to learn, or try to provide a single portal to help these users to do different AI processes. And the fourth layer, we call AI models, that we co-op with NVIDIA to provide some pre-trained models from different domains. In this project, we co-op with Clara to provide several pre-trained models in healthcare domains. And for the third and the fourth layer, in this part, we call ASUS AI Maker. So you can realize that our AI platform provide both functions from cloud resource management to AI ops. As we presented earlier, that our AI platform or our portal have good integration with NVIDIA's Clara SDK, that in our AI Maker or our AI ops pipelines, we try to integrate Clara to provide some good features from pre-trained models to AI or we call AI-assisted annotation, and try to provide more flexible model deployment features. So user can use Clara functions by using our portal to do their AI jobs. So in summary, there are several advantages for using ASUS Cloud AI Platform. For AI Maker, we provide an intuitive portal. It's a very easy to use user interface, and we integrate several AI toolbox, auto-tooling, or NVIDIA's Clara SDKs, try to provide a single shop or single portal experience for users. And we can provide high quality AI jobs by providing hyper-parameter tuning features that help our users to provide or to develop good AI performance. And we try to integrate several NVIDIA SDK to help these SDKs become ready to use features for users. And in our cloud infra or cloud resource management features, it's a cloud native infrastructure that we integrate Kubernetes, and our Kubernetes distribution is CNCF certified. And we can also manage VM resources or storage resources, and to provide multi-tenant or AAA functions to help our customers. For example, in this project, to help hospitals to have a single portal that can help many different PIs or doctors to do AI tasks simultaneously. In this project that we co-op with National Taiwan University Hospital, we are also using GPU servers from ASUS for different models, from ESC 4008 to ESC 8008. It is important to say that because for our own AI platforms, we have even better seamless integration with ASUS servers, and we can provide better performance for AI jobs. ASUS GPU server has good performance to do AI jobs. And besides hardware part, ASUS put a lot of efforts to integrate more and more software, try to help our customers to manage our resource more easier than ever. For example, we integrate software to try to help our customers to do good flexibility and scalability features. And we can also provide intuitive management tools to help our customer to manage their server problems more easier than ever. And of course, performance is the most important part in servers or AI platforms, such like our projects. ASUS has the fastest 2 processors and 1 processor performance. Up to now, we have accumulated 926 #1 results for 1 processor or 2 processors platforms on spec CPU. That's all for my presentation. Thank you very much for listening. If you are interested in our experience or our product, please do not hesitate to contact me. Thank you very much. And I would like to introduce another co-presenter, Dr. Huang, to share his vision and experience on our project Smart ED.
Hello, everybody. Today I would like to share the idea of a smart emergency department with the title of the comprehensive strategy of improving the flow of patients and overcrowding in emergency department via artificial intelligence. So here's the problem we would like to solve. The problem is ED crowding, and actually it is a challenge all over the world. And so as you see in these pictures, there are so many patients waiting on the corridor of the emergency department, and we can see so many patients, and the physicians and nurses, they have very high pressures and high stress when dealing with these patients. So the American College of Emergency Physicians, they define the ED crowding as a situation in which the identified need for emergency service outstrips available resources in the ED. And the Canadian Association of Emergency Physicians define the ED crowding as a situation in which demand for service exceeds the ability to provide care within a reasonable time, causing physicians and nurses to be unable to provide quality care. So actually, this is our initiative of the Smart ED project, and it is also the capstone project of our country. And the initiatives include to improve the throughput of emergency patient flows, and especially to introduce AI in key stages of emergency medicine processes. They will verify the effectiveness with clinical trial in real hospitals. And then we will build the so-called AI professional teams, the iconic medical field, and the top doctor expertise to make a better solution for the ED crowdings. And when we trying to do this project, we have the project execution organization, and the core team include the principal investigator and co-principal investigators and NTU AI centers. And we outreach our resources, and including the industrial partners, ASUS, and the National Taiwan University Hospital, and this is our field, and some industrial liaison office in our university. Then we have some achievement impact expansion. We try to have our result spread to other hospitals, equipment manufacturers, and international exchanges. And then we have our technology professionals. Then we are main co-PI, including the professor from information technologies for the NLPs, robotics, and medical images and computer visions, and also have the PF from the emergency department. And then we also have some co-PIs. They have the emergency medicine experts. Actually, they are an emergency physician with their work in the emergency department in a daily basis. So they knew the real problem and what are the problem in our process. And then we apply the so-called input, throughput, and output models. And then we have protocol re-engineering for the ED patient flow, including the input, patient coming to our emergency department, and in the throughput, include the triage and the diagnosis and event prediction when they stay in the emergency department in an observation unit. And if they have some event, such as intracardiac arrest, then we are trying to do some treatment and prognosis evaluation. And if the patient improves, then we want to discharge patient as early as possible. So we have the output in the discharge. And another output of emergency patient is hospital admission or transfer to another hospitals. So we build our smart ED environment, try to build next generation smart ED, and the core is we will establish our private cloud and IoT platforms. Then this platform can connect to the indoor positioning and also connect to the data from National Hospital emergency medical record. And in this cloud, we can connect to the monitoring and connect to the patient, connect to the computer terminals, and then we can have the our smart ED environment and with our smart devices and smart medical equipment, and then with some AI developed models, then we deploy it on these devices. And we can achieve exposure and more collaborations. And in this part, one of the important industrial partner is ASUS. And this is some key topics of AI optimized ED patient flows. From the patient registration going to the triage, I want to change it to become e-triage. And after that, when the patient have diagnosis and treatment, we want to apply our medical record analysis or some X-ray prediction for the risks. And then even the treatment, we have our in-hospital cardiovascular strategy evaluation. And then if the patient improves, then we can departure the patients. And so this is our timeline when we deal with our medical record in our hospitals. And actually, we take many times to apply for the IRB to get the access approvals, and then go cooperation with IT department to get these data, and then put this data on our GPU's computing resources. And then we have around 1 million emergency registration records in a one main hospital and two branch hospitals. And from this medical record, we establish our retrospective model of the e-triage and medical history analysis and safe discharge. And also we apply this on for the chest X-ray images to do a real-time danger detection and classification, and also with some brain CT of the cardiac patients, we can do some prognosis for the cardiac arrest. And here's some examples of published result. As you see in the lower panels, including the catheter displacement detections for tuberculosis classification or pneumosaurus predict from the chest X-ray. And these results will be presented on the IEE meetings, and the prediction can for the hospital prediction, the AURC is as high as 0.08. Another model is pain score prediction with face mask, and the data will be presented in this year in IEE meetings. And when we build our smart ED environment, we also use some IoT devices. And with the help of ASUS, we have our smartwatch for the medical personnel, and we have patient bracelet, and it can detect the heart rate, blood pressure, and body temperature, saturations, and steps in a real-time basis. And then through our location system and mediated by the smartphone, then we can send this information to our OmniCare platform in our cloud, and then with some API, and then we can output some data and do a real-time monitoring. And so far, we have 830 patients have been enrolled, and 125 healthcare providers have been included in these studies. And we have some vital signs value and critical sign prediction model and detection warning in this project with IoT devices. Then we also have some public exposure of our project and studies. And one of the exposure is in the Healthcare Expo in Taiwan last year. And in this expo, our former vice president visit and give us some good positive feedback. And also we have some media report, including in the website, magazines, and even in the podcast. And we get many feedback from this audience, the readers, and some experts. And it also give us a good idea and let us think about how to improve our models. So I want to have a short conclude here. Is we are trying to have some application of artificial intelligence, and it can assist physicians' decision for patient evaluations and the management in the smart ED models. And this information can improve the patient flows and the crowdings in emergency department with the real-time data input from the hospital information system. Okay, thank you very much.